Shall we start the class then? Okay, guys, I hope I am audible today to everyone. So, today is the fifth day session on the course and maintenance and repair of concrete structure. As usual, first we'll go to the overview. Whatever you have studied in this week, you might have studied about, first you might have completed the module on condition assessment of concrete structure, studying about the testing of rebars in field and lab. Secondly, you might have studied about the next module on which you have studied about the root cause analysis and repair strategy and how to do selection of repair materials. So firstly, the first module about testing of rebars in field and laboratories, why we need testing, why we need NDT testing to test the corrosion. As we can see in the first picture, the rebars look clean from outside. But when we see it as a close-up images, we can see the severe corrosion on the rebars. And when it comes to pre-stress concrete, the corrosion is more severe as compared to the normal steel rebar, because we have already studied that the rust part, they will accumulate inside the strands, and the volume expansion won't be much in case of a pre-stress rebar. Therefore, there will be a sudden disruption causing a severe failure in case of pre-stress rebar. So we need some NDT testing to know about the corrosion inside the concrete on the rebar surfaces. So after that, you might have studied about different methods to test the cross-sectional area of rebar after corrosion. First is the Verneuil caliper, simple method. Second is the liquid displacement method. How much liquid is being displaced by the rebar? From that you can calculate the area. From volume you can calculate the area, right? Third is the Wetz mold. So you will immerse the rebar into the Wetz mold, and after that you will calculate this diameter, this area. Okay, and after that you might have studied about different other methods like DIC method, in which we have white and black speckles. It will measure the stress and strain mostly. And then the image capturing. Image capturing will tell about the different stresses level on the rebar at different points. Is this part clear to everyone? After that, you might have studied about the different test methods to test the corrosion of rebar. First is the half cell potential test. In half cell potential test, what we are doing, we are just wetting the surface, and just above the rebar on the concrete surface, we will keep a reference electrode and make a connection of reference electrode and rebar and calculate the potential difference between these two things. Reference electrode and a working electrode, that is a rebar. We will calculate the potential difference between these two bars, And based on this potential difference, we will map these potential difference. More the negative potential means more the corrosion, chances of corrosion. So based on this mapping, we will get to know where are the chances of corrosion is more. Next is just ASTM G109. The method is almost similar as half-cell potential. Here also we are calculating HCP value only. So we have three rebars which are interconnected, and then we will get the current value and calculate the equal. Okay. Other method is LPR. LPR is linear polarization resistance method. In this method, we are giving potential, we are providing from minus point to, like we will give current value, which will be in smaller range, scan rate, in smaller scan rate, and then and we will get the LPR curve. And the slope of this curve will give us the resistance value. So this 1 upon RP value will help us to provide the corrosion rate. It's an indirect corrosion rate, not the direct corrosion rate. So this is an ACT test which was developed in IIT Madras. Here we are using. So all these test methods which have been already developed, they are mostly of metals in solution. So if we come to concrete system, we have a home developed ACT test where we are using rebar, mortar. We call it as a lollipop samples, and simple three electrode test method we are using, where our rebar act as a working electrode. We will use reference electrode. In this case, we are using saturated a calomel electrode as a reference electrode and counter electrode. In this case, it is nickel mesh. So mostly the counter electrode area and the rebar area, the working electrode area, should have a exact some ratio, mostly 3:1. If you are maintaining that ratio, we will measure using the potential stat. We will measure a PIS, LPR, HCP, all these things we will measure. And from these tests, we are getting the potential value, RP value. Okay. And end of the day, we will calculate the chloride threshold value. So when this RP value, when upon RP value is passing the statistics, we do the statistical analysis on these values, and when these values crosses the mu plus 3 sigma value, then what we will do, we will open up these lollipop samples and collect the powder and do the chloride threshold value. So this is a different type of binders with OPC, PFA, LC3, and their chloride threshold value have been calculated here. Next test is the guarding technique. This test can be used on the field as well as in lab. This is a similar kind of test. A counter electrode, we have three type of counter electrode, and we are calculating same thing, RP value. Okay. Anybody have problem till now? Okay. Now then we will go to the next part. So after this module, you might have studied the next module, strategies and materials for surface repair. So in this module, you might have studied about the root cause analysis and repair strategies. Firstly, whenever we have to go for repair, we have to make sure that we know the root cause of that problem. So in this figure, you might be seeing different kind of problems like delamination, spelling, and then simple cracks. These are the deterioration mechanism. Then when we go for repair, what we are doing? First, we are making sure to cut the concrete surface. Then we do the undercutting of rebars, clean the rebars, and then provide the coating, bonding material, and then we are repairing the system. Okay. After that, you might have studied about different surface repair types and what is the general procedure of surface repair, and then what are the different type of stresses. These are the stresses between old and new material. Mostly old and new material have shear bond problem, or tensile bond problem, or pressure bond problem. And these are the different type of stresses which a new material will face between the new materials itself. Next are the, after that you might have studied about the requirement for different type of repairs. What all you might, different like column and beam joint, if there is a problem in that case, what you should be doing, and what are the main requirements of repair performances. And last, you might have studied different type of strategies for surface repair. These are the main five type of surface repair strategies, which you might have studied there already, right? So in this first case, what they are using, we are using the durable repair material, which is almost similar to base material or a slightly better material. In second case, what is being done? We are using a repair material which is similar to the base concrete or slightly better. And above that, we are using a protective coating. In third case, we are using a better durable material, which are admixtures or fines or some good material, repair material. In fourth case, we have similar good material, repair material with some protective coating. In the fifth case, what we are doing, first we are coating our rebar with the repair material. Then we are repairing the patch using a good material, and then we are providing the protective coating as well. So these are the different strategies which can be chosen for surface repair. Is this clear? Okay. After this, you might have studied about a different selection of repair material. So first thing, what repair material should make sure that it should bond with our substrate. There should not be any cracking, spelling, or delamination. It should have load carrying capacity. Like the repair material should not be just a simple patch thing. It should have load carrying capacity in it, and it should be appearance wise good also. Like it should not be bulging out of the column or something. And next is it should be durable to the service condition. The repair material should have good durability aspects as well. It should not be like porous or something. And other thing is it should give the dimensional stability to the structure. So this is what you might have studied in this week. If anybody have any problem till now, please let me know. If not, then we will go to the question and answer for this one. If it's clear to everyone, then we will go to the questions. So this is our first question. The stress strain response of a substrate material and a repair material is given in figure 1. Stress strain curve is given of the substrate and repair material. Consider a concrete column is strengthened using the repair material and the combined system is subjected to axial load, as you can see from top and bottom. Assume that the end planes are very stiff. Comment on the stress generated in the substrate and repair material when the strengthened column experience an average strain equal to A. Is the question clear to everyone?
No, ma'am.
Think about it. The substrate material will experience more stress than repair material. At point A, we have to see. Repair material will experience more stress than the substrate material. Substrate material will be crushed. Repair material will be crushed. Or both substrate and repair will have a same stress. Ready? Who want to guess the answer?
Ma'am, it will be C. A substrate material will be crushed.
Substrate material will be crushed. Okay. Why do you feel so?
Just reading the curve, I'm saying that, ma'am.
Okay, from curve, you are saying that it's going to be crushed like this because it's
Yes.
okay. Okay, so your answer is correct, but along with it, we can also see that repair material is experiencing more stress, right? So obviously, since stress strain curve is, we say that this is the elastic range and this is the ultimate load, and after that, there is a failure. So from the curve at point A, we can see that substrate material is going to be fail. It's going to be crushed. Whereas we can also see that repair material is experiencing more stress than the substrate material, right? It's a simple question. It's clear
Yes,
to
ma'am.
everyone, right? Okay. So we'll go to the next question then. Non-shrink cementitious material can resist a shrinkage by reducing the surface tension of water, whereas shrinkage compensating material contain expansive agent which acts against shrinkage. What do you think is it's a true statement or a false statement? So there are two type of material we are talking about, non-shrink material and shrinkage compensated material. So what non-shrink material are doing? They are preventing shrinkage. And shrinkage compensating material, what they are doing? They are compensating against shrinkage. So we can say that non-shrink material, what they are doing, they will be resisting the shrinkage and shrinkage compensating. These are the materials which are added which will acts against the shrinkage. In shrinkage, what is happening? The water is being evaporated and material will be shrinking. So these materials, what they are doing, they are providing the expensive agent so that whatever shrinkage is happening, whatever compaction is happening in the material due to loss of water, it is be compensated by this kind of material, which will provide the expansion to the concrete. Whereas non-shrink materials, what they are doing, they are reducing the surface tension of water so that the water does not evaporate into the environment. So this statement is true. Is it clear to everyone?
So these are two different statements, isn't it, ma'am?
Two different statements. Yeah, we are talking about two different type of material to prevent shrinkage. One is non-shrink material and other are shrinkage compensating material.
Okay.
You understand the difference between these two type of materials now, right?
Ma'am, shrinkage compensating material. Where is the application of this one, ma'am? I have worked on with non-shrink cementitious material, which is GP2. Fast GP2 comes under that category. But shrinkage compensating material, where is it applied?
I think mostly it's applied in the colder regions. What I feel, I'm also not sure, but I feel it's applied in the colder regions.
Okay.
Next question. Consider two concretes A and B with identical mix proportion and material except the fineness of cement. Both were found to exhibit plastic shrinkage. Cement used in concrete A is finer than the in concrete B. Comment on the plastic shrinkage of A and B at the end of final settling. Concrete B will exhibit more plastic shrinkage than A. A will exhibit more plastic shrinkage, or both will exhibit similar shrinkage, or Plastic shrinkage in E will be twice than plastic shrinkage in B. So concrete A is more finer than concrete B. What do you think which will have more plastic shrinkages?
Concrete A will have more plastic shrinkages, ma'am.
Anybody else who want to give? Sorry, what did you told? You told this answer only.
Yes, ma'am. A
Okay.
will have more
A
plastic
will
shrinkage.
have more plastic shrinkage as we can see concrete is more finer. That means what will happen? Why will have more shrinkage than B? If it's finer, then should be compacted, more compact structure, right? Why it will have more shrinkage? Anybody who want to answer? So as we can see, concrete A is more finer than concrete B. The cement in A is more finer than concrete B. That means it will absorb more water, and there are chances of what we'll say
Evaporation
this yeah,
or hydration.
hydration. More hydration will be there, which will lead to more loss of water during the plastic stage. We are talking about plastic stage only. So in the initial stage, more hydration will be there and more loss of water can be expected. Okay.
Understood, ma'am.
Okay. So next question. For the patch repair, we prefer simple layouts with less parameters and corner. Why? To minimize corrosion and cracking, to minimize stress concentration, or to minimize shrinkage, stress concentration, and cracking.
Option C, ma'am. This is usually done in roads and all.
Yeah,
Usually, what happens is that whenever there is a patchwork, it is actually protruded out at least by a factor, so that even if there be some sort of a deformation, it can be
solid.
sorted. Yes.
Right. So the answer is C. Patch the We make sure that our patch repair, it should not be like ununiform. It should not be like this. It should have perfect corners and a less parameter. Okay, so that there are, even if there are chances of shrinkage or anything, any cracking or something, we can solve that problem easily. Next question. Based on the understanding from the concrete deterioration mechanism discussed in previous lectures, select the possible mechanism involved in the destructive action of water jet method. Direct impact, pressurization and cavitation, pressurization, abrasion and erosion only, cavitation only, or erosion and abrasion only.
What is this water jet method?
In water jet method, it's like with pressure we are pushing water onto the concrete surface to remove the surface of the concrete. The first repair mechanism is D, cavitation only. Okay. Water jet method is mainly when the first step of repairing, when we have to remove our concrete surface. What we are doing, either we are breaking it with a hammer or something. Another method is water jet method. We apply water with a very high pressure so that the concrete is being removed. Is it clear? Someone told cavitation
I
only.
think
Sorry,
I think option A will be more appropriate.
option A. We
Direct
are
impact,
having
pressure, and
direct
cavitation.
impact, pressurization, and
Yes,
cavitation.
right.
Okay. People are saying A. A is the correct answer. Firstly, water will be giving a direct impact on the concrete surface, and because our water is being released with the pressure, so we have a pressurization, and whenever we can see from our daily life experience also, if we are using water with a very high pressure, it won't cause abrasion, it will cause cavitation. The point at which the water is being put or forced upon, only that point will have concrete removed from that surface, so it will cause cavitation. Question clear to everyone?
Yes, ma'am.
Okay. Next question. As shown in the figure, steel reinforcement in the reinforced concrete members was severely corroded and exhibit significant cross-sectional loss. Okay. Which of the following procedures should be given least preference to avoid steel corrosion in future after repair work? Removal of the corrosion product or rust on the steel surface, undercutting and then providing a relatively uniform electrochemical environment, providing additional reinforcement with sufficient lap length to transfer the load, providing anti-corrosive agent or rust removal on the reinforcing bar, or providing excellent concrete cover material and adequate cover thickness, which is the least preference in
Option D, ma'am.
option
Option D,
or
providing
anti
anti-corrosive agent, rust removers, etc. on reinforced bars without
without
under.
addressing the root cause of corrosion. Okay. Hmm. Anybody else who want to give the answer? Okay. D is the correct answer. So first we need to get to the root cause of the corrosion. If the root cause of corrosion is normally chloride induced corrosion, so even if we are providing anti-corrosive agent or rust remover on it, whenever we are doing patch repair or adding the fresh concrete to the rebar, that anti-corrosive agent won't work much. It will only enhance that problem because I hope you guys have read about halo effect, right?
Ma'am, sorry.
Halo effect. You have read it till now? No, na? I think you will
No.
read it in the future lectures. So, if this is a new concrete and this is our old concrete, if this rebar is inside the old concrete and this rebar is inside the new concrete. So, at this point, the electrochemical properties of our rebar will be different, right? The potential of this rebar and potential of this rebar is different. So there are chances that there is the corrosion will start from this point. It will be a more severe case than the without repair case. So this is a halo effect when our rebar is in two different type of environments. So that the point where this environment is meeting, that point will have the corrosion initiation point. So if we are providing anti-corrosive agent or removal on this part of rebar without even checking the root cause, so we are again providing a rebar in two different type of environment. So this kind of case can be severe for our uh, rebar when we see the corrosion. Is it clear to everyone?
Yes, ma'am.
Okay. Next question. Choose the correct option for obtaining mixes with low shrinkage. Using optimum aggregate content, using aggregate with maximum size as practical, using more cement content, or ensuring adequate curing. If we want to have low shrinkage, what should we should keep in mind?
Aggregate should be of maximum size as possible. B.
Okay. Any other option you think is correct?
I think adequate curing also required.
Okay. Yes.
curing only during the plastic stage, isn't it, ma'am?
Yeah, plastic film, but we are talking about journal shrinkage. So everything will come under it. First option is also correct using optimum aggregate content.
Ma'am, this was also one query I had in that assignments that we are given with. Some questions are having 2 points, 3 points, and all. So I
Okay.
was of a false perception that if it's of a 3 point, three pointer, then I should be selecting only three options. But in my last assignment, it was like four options were right.
Okay.
So how?
I think you should just recheck your answer first before submitting it. There is
No.
nothing like if it's two pointer, only two option will be correct.
Okay.
Okay. If you have any question that you feel is wrong or something, then you can mail me that time. Okay. If you feel some option is incorrect but it's marked as correct, then you can mail us. Okay. I think in assignment 4, one question have that issue. Somebody mailed
Yes.
us. First question itself, right?
Yes, ma'am.
So I have mailed them. I think they will solve this issue. Okay, next question. Match the column A to the best suitable option in column B. So we have different type of material, repair material, and what they can be used in. Fly ash, glass fibers, water reducer, and polyvinyl acetate. What do you think will be helpful in controlling shrinkage or repairing or as a bonding material? What do you think will be a good bonding material?
So for the controlling shrinkage cracking, we can think a water reducer will work more.
And glass fibers will reduce porosity and pore connectivity.
Okay,
No, I think it will be fly as
fly ash
reduce
will
porosity
reduce
and pore
porosity.
connectivity.
Okay,
Yeah, because of the finer particle size, it will fill the all the
pore synthesis.
voids which is present in. Yeah, yeah. If that will be the case.
Okay,
I think glass fiber we can use it for the repair suitable bond.
glass fiber as a
Repair and
replace.
the substrate bond. And water
Okay.
reducer improve workability for the same.
So water reducer will improve the workability. That is for sure, right?
Yeah.
For the same water concentration. And what do you think polyvinyl acetate will do?
Is it a means like
It is a chemical.
I don't. Yeah, chemical that I know. And which type of water reducer, accelerator, or superplasticizer that I don't know exactly.
It's not a superplasticizer. Superplasticizer are mostly PC, polycarboxylic. It's
PCP. Ether, polycarboxy ether based
later.
superplasticizer.
C. A. Fly ash, as you have seen, it will reduce the porosity and pore conductivity. Then
Yeah.
glass fiber improve the sorry glass fiber will control shrinkage cracking, and water reducer, as we have already seen, it will improve the workability. And obviously, if it's a chemical, we don't know what it's doing the bonding material, repair substrate bond. Clear to everyone? You have any doubt in any option?
Ma'am, how glass fibers control shrinkage cracks?
Glass fiber, no, sorry, glass fiber controls shrinkage cracking. Fibers, we are telling, I think in shrinkage chapter we have read now that if we are using fiber uh, in our concrete, it will help in preventing shrinkage because it will help to bind the concrete together. It's sorry, it won't prevent shrinkage, but it will prevent cracking due to shrinkage.
Glass fibers will actually enhance the structural strength of the concrete. So
Sorry, hello, can you repeat?
actually, glass fibers are used for the property of increasing the flexural strength of concrete, uh,
Yeah,
because they bind through all the micropores that
micropores.
hold. Yes.
Hmm.
So how does that control the shrinkage? I don't know. I don't understand.
It is not controlling the shrinkage, it's just controlling the cracking due to shrinkage. See, as you have yourself said, that it is preventing the improving the flexure strength of the concrete, right? So, in the case of shrinkage, there are chances when shrinkage is happening, it's not controlling the shrinkage. Grass fibers are not controlling the shrinkage, but they are helping in preventing the cracking because of the bonding. They are binding the concrete together, so they will prevent the cracking which is happening. It's not preventing the shrinkage.
Okay, ma'am.
Which layout is preferred for edge cutting in surface repair work? A or B? I think we have already seen this question. What do you think? Which type of layout will be preferred? B.
I
Okay.
think B will be.
B we will prefer why? We are reducing the parameter and we are giving a definite edges. This question we have already seen, right? If we are providing a reducing the parameter and providing the edges, what we are doing? We are preventing shrinkage. Three things were there in that question.
No,
Anybody
ma'am,
remember?
kindly explain why. No, no, ma'am. Actually, just
So,
explain why we prefer that one. Means less surface area with sharp edges. Why?
why we are preferring less surface area?
Yeah. And
See,
surface area means okay, it will reduce the means how I can
See,
explain.
if less of these edges are connected to the our old concrete, even if there are shrinkage or any kind of problems with this new material or old material, this bonding will be better. If we have irregular structures, whenever shrinkage will happen, what will happen? This complete material will shrink, and then it will cause different kind of issues in a very small area. But when we are using a definite parameter, even if shrinkage is happening, this complete surface will provide a good bond to the base. In this case, all the surfaces are disoriented. There is no connectivity between the different surfaces. Whereas if we are providing a definite uh, border, then we can say that our connectivity with the uh, base structure is more and it is a stronger bond between those two materials. Is it clear or you want more explanation?
No, it is understood, ma'am. Since it is a as a big homogeneous component, it will have more
More
resistance
strength.
towards any sort of damages.
Yeah. Okay, can we go to next question then?
Yes, ma'am.
So these are the different options why we are choosing this type of structure. It is reducing the stress concentration, more the surface area, more will be the stress there. And secondly, reducing the cracking. And also, this point also, we need less bonding material. If we have more surface area, more bonding material will be required. So from a financial point of view, also we can say we need less bonding material. So this type of surface will be more preferred. And also it will be easy to estimate the repair material quantity. We can directly calculate the area and do. Whereas in this case, it is difficult to calculate the amount of repair material you require.
Ma'am, if it is the case of hello,
Yeah.
excuse me. Ma'am, as you have given the surfaces, then how can we assure that it will reduce the stress concentration at that surfaces? Because the surface means the concentration of the stress will be more, I think, in the surfaces.
No, if you have, see, if you have this type of structure, this type of edge, you will have more stress as compared to this complete bond.
Okay, okay, okay. Got it, got it. Okay, okay.
Got
Thanks,
it, no?
ma'am. Yeah, yeah, yeah. Thank you.
Okay, next question. Match the following. All this test method you might have already studied. So, what LPR is testing? What ASTM C876 guard test and digital image correlation? ASTM C876 is HCP, half cell potential test. To guess any answer, any option?
I think option C will be correct.
Option C for option C. Okay.
Yeah, yeah. Linear polarization resistance corrosion
Initial
rate.
rate.
ASTM 876 for the probability of corrosion.
Yeah.
And the guard ring test
Stress strain behavior.
digitally. Yeah, digital imaging for the. I
DIC,
don't know that one. Digital.
digital image correlation will give the stress strain behavior. Wait, I will go back to that slide. This is the digital image correlation test. In this, what we are doing, we are spraying we are forming the speckles on the reinforcing bar. It is a black and white kind of speckles, and then we are checking the stress strain behavior of this. So we will see like this much area we will check. It will have some black and white speckles. So it will have some particular area in it. After the applying of stress, this surface will change. Maybe it will go like this, or the surface will change. So that area and this area we will compare, and that DIC will give us the stress strain behavior of our rebar. So digital image correlation will tell us about the stress strain behavior. Is it clear? The DIC part is clear to you?
Yeah, ma'am.
Now, what do you think is the correct answer? See, LPR, what we are calculating for LPR. In LPR, we are getting a curve like this, right? And the slope will give us the RP value. And then what we are doing the statistical analysis at different time period, and we are getting this RP value at different time. Exposure time. It can be days, months, or something. And when this value it statistically increases. Initially, it will be like going this, and when it will statistically increasing, at that point, we will break our sample and collect the powder sample, and then we will do the chloride threshold test. So LPR is mostly the test which we are doing to calculate the chloride threshold value. And guard ring test, I think you have seen we have three counter electrode. It is directly giving us the corrosion rate. Okay, so the correct answer is D. Is this question clear to everyone? Or someone have any doubt in any type of test?
Ma'am, in the LPR test also we can find out corrosion rate.
That will be an indirect corrosion rate. That won't be a direct corrosion rate. So in corrosion rate, what we are actually telling, how we are defining corrosion rate. We are telling it is a ICOR value, current rate,
Yeah.
right? But
Yes.
in LPR test, we are calculating the resistance value, RP value. So it won't give us
Initially we are
direct.
calculating after.
Huh. So, what you are saying?
Initially we are calculating RP value. From that we are deriving the ICOR value.
Actually, we are not deriving the ICOR value. From LPR, we usually don't want to derive the ICOR value because there are chances of LPR giving us false readings. Like what we are testing in our lab, many a times we feel that LPR is giving us wrong value. So we prefer we do the other NDT testing, like EIS and all, to calculate the exact corrosion rate, or go for the destructive testing to calculate the corrosion rate. So from LPR, we can get the chloride threshold value, but corrosion rate we won't say because it's not that much reliable test to calculate the direct corrosion rate.
Ma'am, as you told now, means you are doing the destructive test. That is the gravimetric mass loss test or
Yeah,
other test.
mass loss tests are also there, and then if we go for electrochemical testing, then we have PDP, potential dynamic scanning test. From that also we can calculate corrosion rate. That is a destructive test where we will get this kind of curve. I don't know if you have seen or not.
Yeah. Means for that we need the pore solution.
We need the pore solution for
So
LPR test also. We are concrete in mortar. This test, but the electrolyte we are using the pore solutions. And for this test,
okay.
you are telling we are doing steel in solution, right? This test is
Yeah. I
mostly
mean,
done
yeah, you
steel
are
in
immersing the
corrosion.
steel specimen in the pore solution.
Yeah. So this test, that's why we try to we either should have like develop it for the steel concrete test. I don't know if somebody have done it in concreting till now or not, PDP testing, but mostly this test is for steel in the solution only. From this, you can get the passivity value or you can get the corrosion initiation value.
Okay.
Next question. How to ensure proper load transfer to surface repair on a column? By ensuring jacking until the repair is mature, or using the material with maximum volume change, or providing the stress strain compatibility between substrate and repair material, or using the material with higher creep. What do you think is the correct answer?
First, A option is mandatory.
Yeah. Correct. Why we are providing shoring and jacking to
Achieve the desired strength. After
A.
that only we should be loading it. Uh,
Yeah. We are providing jacking just to transfer the load so that our
yes.
repair material doesn't have the load in the initial state itself. After it's completely cured and all, then only we will remove the
Then
jacking.
option C might be there because stress and compatibility should be there.
so that our bond is proper between the two substrate and
I don't think creep has any sort of importance here.
no, it should have low creep actually.
Yeah, it should have low creep. Yeah.
Okay.
A
If
and
you
C.
have yeah, ANC is correct, but you can't say creep doesn't have anything. Creep will have it, but it should have low creep. If you have more creep, then there are chances that your repair material will just fall off from the substrate. Okay,
Okay.
answer it ANC, I just all have said. So that's all for today. If you have any doubt in the lectures or assignments or something, you can tell me. Thank
Thank you, ma'am.
you.
Thank you.
Then I'm closing the class for today. Thank you, everyone.